Hello students! Welcome to the first of our virtual lectures. This is a new experience for me. I've never lectured in my basement before. I presume it's potentially a new experience for you. This set of lectures is going to be about the fundamentals of introductory physics. I would like to be able to provide you in these whiteboard lectures a lot of the theoretical and fundamental approaches that we will use in practice during class time to solve problems. And so these are there to supplement what's in your book. I'm going to try and provide you some guidance through clicker questions or multiple choice questions during these lectures so that you have a way to check yourself and to check what you've learned. And so we're going to try this out. We're going to see how it works. I'm not going to lecture during class time. I'm going to lecture during now. And hopefully the amount of time you'll have to sit and actually see or listen to me is about the same. I don't want to have this go much longer than a few minutes per lecture. That way you can either speed me up or just flip to the important parts and see what you've missed, but you can also back up and try and understand the concepts maybe a second time. And so today we're actually going to start off with what's on the board here, and we're going to talk about vectors. Vectors are a very important component in understanding physics. They provide us the ability to recognize where things are in space. We give them a lot of importance, and we're going to go through and discuss some of the aspects of vectors today, some of the details. And so vectors come in a number of different varieties, and in dimensions we have a 1D vector, which is a point on a number line. So for example, if I have this point here, it's some distance along the x-axis in one dimension, and I say from the origin here, this is 0, 0, out to this point, this is my vector that points along the x direction. I can also work in multiple dimensions, so 2D, a vector in the two-dimensional plane. These are orthogonal sets of axes, and so this would be the x-axis, for example, and this would be the y-axis. And in 2 dimensions, we have 2 positions along each axis. So here's one position here, here's another position here, and the vector that makes up these 2 components would lie in the xy plane. These are Cartesian coordinates, and so that distance here, would represent the vector that points from the origin to this point in space. So this has 2 components, where this had only 1 component. Let's say this is the distance, let's give this a distance of 5. Let's extend that here, a distance of 5, and let's say here we go a distance of 3. And so for this vector, its point in space, where it's pointing from the origin, which is 0, 0, is now a 2-dimensional vector with x component 5 and y component 3. Now, we mostly are going to work in 2 and 3 dimensions, and so in 3 dimensions, this looks a little bit different. We still have our coordinate system, but now we go to a 3-dimensional representation of our points in space, and we work in what's called a right-handed coordinate system. And we'll talk a bit more about that. That's a detail. And so, for example, I would label this the x-axis, then I'd have to label this the y-axis, and I'd have to label this the z-axis. And so if I want to know where a point in space resides, let's say I want to know where this point is relative to the origin, 0, 0, 0, I would draw a point in space and its vector that connects it from the origin to this point. And so now I can identify the points in space that define this vector. So we're going to have a point here, point here, point here. And so now I can identify the three components that make up this particular vector. Let's go with what we had before. So we'll go like this. And so now we have these components. We'll call this x, y, and z. And there we go. So now I can represent this point in space with these three components. This is the x, this is the y, and this is the z. And so these are now scalars that help me represent this vector quantity.